Example A, determine the term which is independent of x in the expression of x plus 1 over x power of 8. Okay, independent of x means x power of 0. Okay, we want to get the term with x power of 0. So x power of 0 is equal to 1, which means the term has no x. Okay, so we want to use this formula, 3r plus 1 formula. Okay, for the binomial expression here, we compare with general form a plus b power of n, so that you can get the value of a is equal x, and then b is equal 1 over x, n is equal to 8. Okay, after that, you can substitute into this formula. r plus 1 is equal n 8r, a is x, power of n minus r, 8 power of r, and then this is 1 over x, power of r. Okay. Next step, we can simplify here the bracket. We open this bracket, so we get 1 over x power of r. Okay. So the next step is we have to think how to get r. Okay, to get r, we have to collect the like terms here of x. Okay, which is, you can write x power of 8 minus r times x power of negative r is equal to x power of 0. Okay, because we want to get, this one is referred to independent term, or other words we call as a constant, because x power of 0 is equal to 1. Okay, then you apply rule of indices here. 8 minus r plus negative r is equal x power of 0. Then x 8 minus 2r is equal x power of 0. Since we have same base of x, then we can compare the index. 8 minus 2r is equal to 0, then r is equal to 4. Okay, after you get the value of 4, r is equal to 4, then you substitute into the first step here. T5 is equal to 8, 4, x power of 8 minus 4 times 1 over x power of 4. Then 8, 4 we can write as xc4. Simplify here, x power of 4, 1 over x power of 4. Press your calculator, you get 70. X power of 4 minus 4. Then simplify, you get 70. This is the constant term or independent term. Example 9. Determine the middle term in the binomial expansion. Okay, of 3x plus 2 over 3x cubed power of 9. Okay, remember that if we have a plus b power of n, okay, so we have n plus 1 terms. Okay, that means if we have power of 9, so now we have 10 terms. Okay, so the middle term should be T5 and T6. So we have to find these two terms. Okay. Okay, you may try to find for both terms, T5 and T6, and by your own first, then you can check with these solutions. Okay, this is the answer for T5. And then you try to find T6. Example 10, the coefficient of x cubed is 4 times the coefficient of x squared in the expression of 1 plus x power of n. Find the value of n. Okay, alright, so firstly we have to compare with general. Okay, general binomial expression a plus b power of n. Okay, which is, we can state the value of a is equal 1, b is equal to x, okay, and n is equal to n. Okay, since if we have the word coefficient, okay, so it means we have to use this formula. Tr plus 1 is equal to n, r a power of n minus r b power of r. Okay, right. So we substitute into this formula tr plus 1 n r. A is 1 power of n minus r x power of r. For the term of x cubed, we want to get the coefficient, so that means r is equal 3. Where I get the r is equal 3? Because since we have x cubed, so that means this one should be x power of 3. So then you can compare r is equal to 3. Once you get r is equal to 3 here, that means you can substitute here also 3, this one also 3, and this is 3. So thus you get T4. T4 is equal n3 x power of 3, where the expression of 1 power of n minus 3. Any value of 1 power of something, doesn't matter you have positive or negative number, is going to 1. Okay, 1 power of 2 also equal to 1. 1 power of 100 also is equal to 1. So we don't have to put here. Thus, T4 is equal to n3 x power of 3. The coefficient is n3. Okay. Same thing for term of x squared. R is equal to, because this one we want to get terms of x squared. Thus, we compare r is equal to 2. Now we get 2 here. Also substitute here is 2. This one 2, and this one also 2. It becomes T3. T3 is equal n2, and then this one 1 power of n minus 2 is equal to 1 x squared. Thus the coefficient is n2. Okay, from the sentence of the question, the coefficient of x cubed is 4 times the coefficient of x squared. Okay, now we take back the coefficient. This is our coefficient. Okay, coefficient of x cubed. N3 is 4 times the coefficient of x squared. So N2. Okay, so now you have to use the formula. Okay, NR, either you can use as NCR, or now we have to use this formula. N factorial over n minus r factorial times r factorial. Okay, so N3 is n factorial over n minus 3 factorial times 3 factorial is equal 4 n factorial over n minus 2 factorial 2 factorial. Okay, and then you can simplify here. Same expression, you can cancel n factorial with n factorial. Then I cross multiply here. Okay. Okay, because we have here n minus 2 factorial. 2 factorial is equal to 2 times 1. Okay, 4 n minus 3 factorial. 3 factorial is equal to 3 times 2 times 1. Okay. Okay, after that you can simplify. N minus 2 factorial, this is 2, is equal 4 n minus 3 factorial. 3 times 2, then you get 6. Okay, after that you can simplify these numbers. Okay, so I get here then n minus 2 factorial. 24 divided by 2, then you get 12. N minus 3. Okay, to solve for n, we have to think, okay, between n minus 2 factorial and n minus 3 factorial. Each one we have to expand so that we can get same expression and we can cancel. Okay, between n minus 2 factorial and n minus 3 factorial, we can expand this expression. N minus 2, after n minus 2 is n minus 3. Then we have to put factorial, because we have the same expression on the right hand side. is n factorial also. Okay, now you can cancel here and also this one. Thus n minus 2 is equal to 12. Thus n is equal to 14.